Core 2, Summer 2011. We have a geometric progression. First term A is 50 and R is 0.9, 90%. So the ninth oscillation will be 50 times 0.9 to the power 8, and that gives us 21.5233, 21.5 centimetres to 3 significant figures. Work out when a term is less than 10, so that's when AR to the power n minus 1 is less than 10. So that's 50 times 0.9 to the power n minus 1 is less than 10. Dividing both sides by 50, get 0.2. And if I rewrite this in log form, it's when the log to base 0.9 of 0.2 is less than n minus 1. And I can do this because my calculator will work to any log. N must be greater than 15.275 plus 1. N must be greater than 16.275. So after 16 swings, i.e. the 17th, it will be less than 10. Work out the total distance travelled after 20 swings, so that's A upon 1 minus R to the power n all over 1 minus R. So A is 50, R is 0.9, and we're interested in 20 swings, so it's over 1 minus 0.9. Typing that into the calculator, I get 439.211, 439 centimetres. B, then we're asked to do a proof, and we have an AP. So the sum of the AP will be the first term plus the second plus the third right up to the last term. If I write that underneath, but I'm going to write it in reverse. Right down to the first term, and then I'm going to add these together. Sn plus Sn gives me 2 times the sums of an AP. A plus A is 2A, and then we have an n minus 1B. If I have A plus A again, I have another 2A. And n minus 2 plus 1 gives me another n minus 1 times D. And we can see that works when we add the last to the first. Every opposite term added together gives me 2A plus n minus 1 times D. I had n terms, so I have n times 2A plus n minus 1 times D. This is twice the sum. I only want the sum, so it's n over 2 upon 2A plus n minus 1 times D. In the mark scheme, they've referred to the last term as L. I've used the nth term, and then at the end they've replaced L by A plus n minus 1 times D, and you end up with the same answer.